Dot and whisker plots, Pareto charts, pie charts. Dot and whisker plots are mostly the only thing we're going to do by hand. Most of the time you're going to do histograms, even though you'll learn to make one by hand. You have to learn how to make the frequency distribution for them by hand. But most of the time when we actually construct histograms, bar charts, pie charts, we're going to do it in Excel. We're not actually going to do it by hand. So you probably learn to do it by hand once, just so that you'll have an idea of what everything represents. Stem and leaf plots, on the other hand, you can do those with software, but they're really easy to do by hand. And you really don't want to do a stem and leaf plot with a big, huge set of data, like 2,000 numbers. You want to. This is something that you do if you only have a small set of data, and it's really easy to do. So, and by the way, I'm neither a Gators nor a UT fan. This happens to be Ms. McNabb's worksheet, so I'll just make my disclaimer now. The only time I favor the Gators is when they're playing UT. Because I know that's a bad thing to admit in the state of Tennessee, but I work for TBR and UT gets all the money, so I root for whoever's playing against UT. And if I have a favorite football team, it is actually Notre Dame. And we all know Notre Dame doesn't have a real great track record, so that's okay. You can feel sorry for them. I root for the Cubs, too.
Oh, God.
Anyway, stem and leaf plot. You need to draw a straight line. A straight vertical line. And your data needs not to have more than 3 digits. Otherwise, this is not useful at all. So it's for small data sets that are either just double digits or at the most 3 digits. Because as we construct it, you'll see why it would be awkward to have to do it if you had 4 or 5 digits of data. So this data is all 2 digits. The tens digit is going to be our stems. That's going to be our stem. And our tens data, this data looks like it goes from a low of 17 to a high of 42. 62?
Yeah.
Okay, yeah, I see the 62. So what we have to do is we have to include all possible, even though we don't have any 50-somethings, we have to include 5 as one of the stems, because if we don't, it's going to distort what the shape of the graph looks like. So we're going to start out with a digit. We could start out with 1, but it doesn't have any data anyway, so we're going to start with 2, and 3, and 4, and even though there are no 50-somethings, we're going to put 5 in here. And then the largest one was 6. And then we're going to go through the data, and we're going to use the ones digits as the leaves. And once again, it's important, don't leave any digits out on the stem.
Where's the 1?
Oh, the 1 should be up there, yes, because we have a 17. So it's really important that we included that 5. So going through the data, we're just going to go through pretty much in the order that's given to us. 34 is represented by putting a 4 after the 3, so now we have 34. And then the next one is 21, so we'll put a 1 after the 2. And the next one is 28, so we'll put a 28 after the 2. And then the next one is 17, so we'll put a 7 after the 1. And then the next one is 25. And the next one is 62. So we put that down there with the 6. And then 38. And then 42. And then 26. 23, 21, 17, so we'll have another 7 at the top, extend my line a little bit, 21, and 41. Now what that data does, what that particular graph does, is it gives us an idea of the distribution of the data. We can tell that the modal category of the data is the 20s. And we can tell that 62 is pretty far away from everything else, so it has the potential to be what we might think of as an outlier. In fact, if you turn this on its side, and you look at it this way, if you've been careful and spaced your numbers carefully, what you actually have, without having to construct a frequency table or even a piece of graph paper in most cases, is you got a really nice histogram with very little work. Okay? And in fact, that histogram is skewed which way?
Left.
Be careful, because skew doesn't follow the tall. Skew follows the short. So this is skewed right. It starts out tall and goes small. Skewed left starts out short and builds up. So this one's skewed right. It's easy to tell that just by looking at this sort of histogram. That was a lot faster than making a histogram. How long did it take y'all to make a histogram the other day? At least a couple of minutes. Because you had to sort the data out, put it in the different categories. I mean, actually drawing the histogram was the easiest part. Sorting the data out was the hard part, and this sorts the data out for you as you go. So it makes it a little bit easier. Now the second one says University of Tennessee has had several different professional preseason rankings represented by the AP poll. This is for the years 2002 through 2007. Listed below are the rankings for the Tennessee Volunteers. Create a time series chart. Well, a time series chart, as it implies when it says time series chart, your horizontal axis is going to represent time. And this time is being measured in years, 2002, 3, 4, 5, 6, 7. So this would be year 2000, which we'll just represent with a 0. And I'll just say that the time is being measured in years after 2000. So this would be 2001, this would be 2002, 2003, 2004, 2005, 2006, 2007. And then our rankings are going to be on this axis. And we're going to try to evenly space those, just like we tried to evenly space this. And the rankings go from 5 to as high as 23. So we're going to have to be careful because we're going to need to get about 20 some odd marks on here. So rather than mark every single one, I'm going to say that this represents 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and so forth. So I'm going to mark that off in 2s because I have a limited amount of space to finish this graph. So then we're going to plot these just like you would plot a graph in algebra. In the year 2002, their ranking was 5. Okay, here's 2, 4, 5. And just to make my life a little easier and make sure I don't get too far off on this, I'm going to borrow a card out of this deck. And 5 would be right about there. So I'm going to go over to 2 and put a dot for 2, 5. And then in 2003, it was up to 12. So that would be up to about here. And then 2004, it was at 14. And then 2005, they're back to 3. And then in 2006, they're at 23. And then in 2007, they're back to 15. You could label all those points with their ordered pairs if you wanted to, but here's the point to the time series chart. We don't know what their ranking was in 2001 or in 2000, so we don't even start there. We start at 2002 and we connect the dots. And we stop at 2007 because we can't make any implications after that. Okay? So basically, a time series chart is simply plot your ordered pairs and then connect each consecutive ordered pair with a straight line. And it shows you that the rankings went up, down, back up, and then back down. So it shows trends over time. Okay? Now, the one thing I didn't mention over here on the stem and leaf plot, and since we've got time to do it, I am going to mention this. You can also, if your data, for some reason it would be useful to do it, we could redo this stem and leaf plot and make something called an ordered stem and leaf plot. Since I've already got the plain stem and leaf plot, it's going to be actually pretty easy to do it. If you were going to do this before you made this, you would want to rank order your data. But if I rank ordered this, it lets me see something that's going to be really useful here in a few minutes. So there's my 1, 2, 3, 4, 5, 6. And since there's only one leaf for 6, I'll go ahead and put it in. But I'm going to put the 1 and the 2 in numerical order. And I'm going to put the 4 and the 8 as they are already in numerical order. When I come to the 2, I've got 1, 2, 3 1s. And then I've got a 3. And then I've got a 5. And then I've got a 6. And that's it. And then at the top I have 2 7s.
Yes,
Oh, yes, I see the 8 now. Thank you. And I have those 2 7s. Now, this is called an ordered stem and leaf plot, meaning your data is rank ordered before you put it in the plot. And here's the good thing about that. There's something you can do with this that you can't do with this one. And this is going to come up in the next chapter. Not only can you see the spread of the data, and you can see the distribution of the data, but when we get into chapter 3 today, we're going to talk about 3 measures of what we call center. So here's your preview of coming attractions. And there are 3 of these. One is called the mean. One is called the median, and one is called the mode. And we can actually, with this data arranged in the way that it is, we can actually find all three of those fairly quickly. This one especially is easy to find, as is that one. The mode is the one that shows up the most often. It's the one that has the highest count. And it's quick to see, if I've got these in order here, that the mode is 21. It's also pretty quick for me to be able to find the median, because these are in order and the median is the one in the middle. But they have to be in rank order. Not just the middle of the set of data, you have to rank order them first. Well, these are rank ordered. And since I already know from looking at the table, I have 2, 4, 6, 8, 10, 12, 14 pieces of data, that 7 are going to be below the median and 7 are going to be above the median. So all I have to do is find the 7th and the 8th numbers. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So the median here is halfway between 25 and 26.
You put it like that? So it'd be 25.5.
25.5 is halfway between 25 and 26. There's not an actual median that is one of the data banks. But I can say half the data is less than 25.5 and half the data is more than 25.5. It's just marking strictly the absolute center of where the data is.
Yeah.
Okay? There's another measure, it's actually a measure of spread called the mid-range that sounds a little bit like the median, but it's not. The mid-range, range means the lowest to the highest. So 62 minus 17 is the range. But the mid-range is the range divided by 2. So 62 minus 17 is 45?
45.
So it's 22.5.
Yeah.
Okay? The mid-range really doesn't tell me much. Range actually kind of tells me more. It tells me that the data are spread out. There's 45 difference between the highest and the lowest. But the problem here is that the range measurement and the mid-range measurement only take two numbers into account. So it doesn't tell me a whole lot about what happens in between those two numbers. So they're not very useful. This one is the one that's the most work. Do you know how to average your grades? How do you average your grades?
I don't get it about the money you have.
Now, as long as they're equally weighted, you add them all together and divide by however many you had. You know, if we have 4 tests in here, you're going to add your 4 test grades together, divide by 4, you'll have your test average. Well, I can do that here too, and I can almost do it in my head, but I'm going to be lazy and I'm going to use a calculator. In order to find the mean, I need to take 17, and there's a faster way to do it too that you'll learn, but since we're just kind of looking at things we can do quickly, 17 plus 17 plus 21 plus 21 plus 21 plus 23, 25, 26, 28, 34, 38, 41, 42, and 62. So that's a total of 416. and it's divided by 14 numbers.
We round to the nearest tenth or?
In this case, I would round to the nearest tenth. So even though it comes out to be 2.29.714, it's okay to round that to one decimal place. The key for rounding is if there's no digits, if there's no decimal places in your data, it's integer values, round to one decimal place on the mean. If your data had one decimal place, then round to two decimal places. You always keep one extra decimal place on your mean. You always do one extra. So we're going to call that 29.7. And that's close enough. Okay? So you've learned about Chapter 2, but you've also learned a little bit of what's going to go on in Chapter 3. Calculator out of the way. I'll let you read the little cartoon, the very corny little cartoon up there. But what we have listed in this table here is the ages of some students in a section of Math 1530. And we're supposed to create a dot plot of the ages. Dot plot. Honestly, dot plots are much easier to construct if you've got graph paper, but here again, we can do it without graph paper. You really don't even have to have the vertical line. You can actually get by quite well with having just the horizontal line. So this is not really necessary. Some people put it there because in graph paper it gives you kind of a scale to go by, but we're going to be able to do this pretty well without that. So I noticed looking, scanning through the data, it seems like most of these students, they begin at age 20 or at age 18, and it looks like the oldest one is 42. Everybody agree? Okay, that means that I need to start at 18. And I'm going to count by 2 since I got to go all the way to 42. So here's 18, 20, 22, 24, 26, 28. Here's 30, 32, 34, 36, 38, 40, and I don't need to go past 42. And you can label all those in, or just label enough for you so that you can show where everything is. So I've got a student that's 18 years old. What I do is I put a dot to represent that student. And then I have one that's 19. Well, 19's halfway between 18 and 20, so I put a dot to represent that student. And then I have a 20-year-old. And another 18-year-old, so I'll put another dot, about equally spaced. And then I have a 35-year-old, so here's 30, 32, 34, 35, right about there. A 26-year-old, 2, 4, 6, so there's my 26-year-old. Another 18-year-old, a 21-year-old, a 20-year-old, that's the second 20-year-old, so I have another dot, a 24-year-old, a 38-year-old, 2, 4, 6, 8, another 18-year-old, a 24-year-old, a 21-year-old, a 22-year-old, an 18-year-old, a 19-year-old, a 42-year-old, 27-year-old, 4, 6, 7, and another 19-year-old. Skew right, skew left. skewed right, because it's tall on the left and decreases, so skewed right. Okay, and there's quite a spread there. There's quite a bit of spread. And here again, just like I could find the median pretty quickly, all I have to do is count dots. I've got, let's see, 4, 8, 12, 16, 20 pieces of data, so the 10th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The median is 20-year-old. And the mode is an 18-year-old. And if I wanted to go to the trouble to do it, I could even, without having the data at all, I could even use the dot plot and actually add up all the ages and divide by the 20 students and come up with the mean if I wanted to. Plus, I can find the range. The range is from 18 to 42. And I can find the mid-range by subtracting 18 from 42 and dividing by 2. But there again, all I'm doing is counting an 18-year-old and a 42-year-old, so it doesn't really tell me anything about how the data is skewed to know that. So mid-range is not a real good measure of center or spread or anything else. The easy stuff really is of much benefit.
Do we have to label this graph? It says right there. Don't forget to label the graph.
Okay, yes, and we actually probably should have labeled the others too. I did not. In Excel, that becomes automatic, and I get lazy with doing it by hand. But if you were going to title this graph, what would you call? What would you say this graph is showing you?
Like ages, and then put years on the.
Well, actually, I would just give it a title: ages of Math 1530 students. And then I would call this axis ages, and then I would make a note that I'm measuring that in years. Okay? Graphs are not really very informative, no matter what kinds you have. They're not very informative if you don't at least say what the graph is about. So if we were doing this graph, in addition to saying that its rankings over time, we might want to put up here AP poll preseason rankings. And since we're looking here at points scored by the Gators per game, then we could put points scored by the Gators. So your graph really needs to have a title so that people know what it's talking about. Listed in the table below are some of the types of vehicles sold at a recent auction. Create a Pareto chart. Now, there are two kinds of charts that look very similar. There's only one distinction between them. A bar chart is a way to draw a chart of data that is categorical in nature. Okay? These cannot be arranged in any kind of meaningful numerical order. They can be rank ordered by size. The motorcycle would be the smallest. The next smallest would probably be the sports car. Then the next one would probably be a sedan, and then probably the van, and then finally the truck, or maybe the truck and then the van. These days and ages, it's kind of difficult to tell. But as far as actually having numerical value, they don't have. So if I were going to make what's called a bar chart, and notice this says Pareto chart, and I'm not going to talk about Pareto until after I've shown you the bar chart so you can see the difference. If I were going to draw a bar chart of this data, the bar chart would look like this. I would know that this is my frequency axis. Or you could say it's the number of vehicles if you wanted to. And this is going to be my type of vehicle. And what I'm going to do here is I'm just strictly going to go down the list. So the first one I'm going to list is going to be a van. The second one's going to be a sports car. then a sedan, then a motorcycle, and I think I didn't make my axles long enough. And the last one's going to be a truck. And then what I'm going to do is the van is going to have to go up to 8 units. So here's, and I need for this to be able to go up to 20. So again, I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And the van needs to go up to 8. So 2, 4, 6, 8. And here's the thing you're going to have to be careful about. You want these bars to be the same width. You don't want one to be a little skinny, the next one to be this wide, the next one to be this wide, the next one to be this wide, the next one to be this wide. You need to keep them of even width in order to be not misleading about your chart. So then on my sports car, I'm going to go up to 6. I'm going to try to keep that about the same width as what the first bar was. And then on my sedan, that needs to go up to 19. So that's going to be pretty tall. And then motorcycles, we only have 2. So it's going to be pretty short. And then the trucks is going to go up to 12. So I'll borrow my card again. 2, 4, 6, 8, 10, 12. It's going to have to go up to about there. And this really and truly does work better with graph paper. That is a bar chart. That is a bar chart. The bars do not touch because there is no place where a van suddenly becomes a sports car. They don't come together in value. And there is no place where a motorcycle can morph into or round up to being a truck. They're not like numbers, they're categories. But now, it says make a Pareto chart. And a Pareto chart it is an ordered bar chart. By frequency. And the highest frequency is first. The highest frequency is going to come first. And the easiest way, honestly, to do this see just the data. If it was a bigger table than this, I would probably want to plug it into Excel and have it sort that from highest to lowest for me. And when we do Excel, we'll actually learn how to do that. But I can tell which one is the highest. My highest frequency here, the sedan is going to come first because there's 19 of those. And then trucks are going to come second. And then after the trucks is going to come the vans. And after the vans is going to come the sports cars. And then the last one is going to be the motorcycles. Okay? But other than that, it's the same kind of chart. So the sedan is going to be 19. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. label that the sedan. And then second is going to be the trucks with a frequency of 12. So here's 2, 4, 6, 8, 10, 12. And then the next one's going to be the vans with 8. And then the next one's going to be the sports cars with 6. And the last one's going to be the motorcycle with 2. And that is a Pareto chart. And I'll label enough of the tick marks so that you can tell that I wasn't counting by ones, that I was actually counting by 2s. So there's a Pareto chart as compared to what a bar chart looks like. Now the question I have for you, which one was more useful? The Pareto chart in this case was more useful because if this were the number of vehicles sold by a dealership in a month's time or a week's time or whatever, this tells them that their sedans are outselling their other vehicles. So they probably want to keep more sedans and more trucks in stock and fewer sports cars and motorcycles. Okay?
I believe it's more organized. This is more, Pareto's more organized.
It's very much more organized and it's very useful. There's some other context you could use this in too. Companies look at various ways they've lost money. There's a lot of ways companies lose money. They lose it through waste because, you know, maybe they're a grocery store and food spoils. They can lose it through breakage. They can lose it through employee theft. They can lose it through shoplifting. So there's any number of ways, but if they want to see where their number one loss is coming from in their stock, they would want to look at the data in a Pareto chart so that they could identify that one big category and take steps to rectify that. So anytime you're looking at something where the highest frequency category is important, you probably want to do a Pareto chart. If the order really doesn't matter, you know, if you're just looking at the various different categories, then you just do a plain old bar chart. This is the first, last, and only time we are ever going to do a pie chart by hand. Just say that up front. But it's a pain. It's truly a pain. In order to do a pie chart, we have to show proportionally what flavors of potato chips there are that are being sold by a street vendor on a particular Friday. Before we can even start, we have to figure out how many total bags of potato chips did he sell. So we're going to first grab a calculator. And take 62 plus 118 plus 45 plus 29 plus 84, and he sold a total of 338 bags. And I'm going to use that to create what is called relative frequency, which I'll just denote RF out here. I believe you probably learned how to do relative frequency when you did histograms. Okay, so 62 over 338. Actually, I'm going to be really lazy. I'm going to use the calculator to its full advantage. I'm going to hit Stat, Edit, clear out the data that's in here because I don't need it. And I'm going to enter in 62, 118, back in there. $45, $29, and $84, because rather than me have to do 5 division problems, I'm lazy. I'm going to get it to do all 5 of them at once. So I'm going to tell it to take all those numbers in list 1 and divide those numbers by 338. Now I don't have to do anything. So the first one is about 0.18. Just go to 2 decimals. And 0.35. And 0.13. And 0.08 and 0.25. And I'm also using the calculator because of the other thing that I'm going to have to do. A circle has 360 degrees in it. I need to decide how many degrees of that circle that each one of these proportions is going to be. So what I'm going to do is I'm going to go over here to the top of list 2. And I'm going to say, take all those numbers in list 1 and multiply those numbers by 360 degrees so I'll know how big to make each piece of the pie. So as far as my pieces of pie, my barbecue flavors is going to take up about 66 degrees. And my next one will be about 126 degrees. We'll call it 125 because that's actually pretty close. And 47.9, we'll call that 48 degrees. And then we'll call the next one 31 degrees. And the last one we'll call it 89 degrees. So here's what we're going to have to do on this circle. I have to start somewhere. So the first somewhere I'm going to start is this is going to be 0. And I'm going to have to measure to where I have 66 degrees. So measuring from there, here's 60, here's 65, so 66 is about right there. I'm going to grab my handy dandy tape ruler. And this is going to be barbecue. And my barbecue is really about 18%. And then the next category is going to have to be 125 degrees. So I'm going to set my 0 back right here and count around. If I can get it in there evenly. I don't know which is warped, the paper or the protractor. 125 would be right about here. This is the plane shits.
Can you like zoom out a little bit?
How about I do this?
Thank you.
Sorry. Because I can still see the top and I know you got it written down.
Would you care moving the calculator too?
Well, actually, we don't need it anymore, so let me just set it down. And that looks like an oval there, but I swear it really is a circle on the paper. You can see on your paper it really is a circle. And the plain chips makes up about 35%. And then I have sour cream, and that's 48 degrees. So again, I'm going to pull my 0 back down here. And 38 degrees is about right there. I'll solid my lines up now since I'm getting down to the point where I can kind of tell where the center is. So that is 48 degrees, which is 13%. And since my labeling is getting a little bit tight there, I'm going to just say that's sour cream and onion. And then I have 31 degrees and 89 degrees. And if I find either one of those, the other one's what's left. So starting here at 0, I'm going to try to find 31 degrees, which is right about there. And that would be 8%. And that's salt and vinegar. And the remaining are cheddar, which is about 25%. And we spent more time doing a chart that Excel could have done for us in about 15 seconds, including the time it would take us to type in the data. Okay? This is the data chart that I sent out. I'm just going to add a sheet to it. Well, it's supposed to let me add one down there. It's being contrary. I bet it's not going to let me edit it. Just wait a minute. So I'm going to do some real quick typing here. Actually, since it's already 11 and we got our class 11:20, I'll just let you out a few minutes early today rather than take a break. So just don't forget to turn in your homework. So I'm going to type in that chart right quick. Actually, I could probably even do this if I thought it's still up here. No, I don't have the right one up here. Let's see if I can grab the right one. Download it.
Do you want the sampling worksheet turned into? Or do you want to keep?
I want you to hang on to it so we can make sure that everybody's getting the right answers. I would actually like to. think it'll work from Adobe, I'm not sure. Almost. Believe it or not, that took longer than what it's going to take us to make the chart. We're going to go to Insert. Look for a chart that looks like a pie chart at the top. Pick it. And the problem is, what I needed to do was not have the whole chart highlighted. So I'm going to undo it. Highlight, oh, whoops. And I have a mistake here, so I need to get rid of that. I want to highlight only the frequencies. Insert, charts, pie chart, and then I want to add labels. Format. Where's my data labels? Actually, let's use the quick layout. I think I can do it from there. There we go. Let's make it a little bit bigger. Regular pie chart. Made for us. And you can edit it, you can change the chart title. Math teachers should really be able to spell better than that. You can make your labels bigger or different colors. You can make your pieces different colors. There's bigger labels for you. So we'll play around a lot more with Excel to make graphs and charts than we will spend on doing any of this kind of thing by hand. Okay? So we are pretty much officially finished at this point with Chapter 2. That takes care of all the graphs and charts. We've even introduced a little bit of Chapter 3. The only other things that we'll need to do in Chapter 3 is, I'm not going to lecture on Chapter 3 right now, but I am going to show you the shortcut way to do things. Let me just arbitrarily pull up the data file from Excel that you sent me. I'm going to copy out, just out of curiosity, the number of texts that you sent. And I'm going to add that to this chart. I can get descriptive statistics. Let's move that out of the way. I can get descriptive statistics of these numbers all very quickly. So even though I'm going to show you formulas next time, I'm going to give you some hope that you don't always have to do everything by the formulas. If I want to find the median of this set of data, I don't even have to put them in rank order. All I have to do is go up here to the FX button, tell it that I would like to see the statistical formulas. They're in alphabetical order. I'm going to scroll down and tell it I want it to find the median. And then tell it which set of data I want it to find the median of. And it tells me. I didn't even rank order it, didn't do anything. If I want to find the mean of that set of data, I click that FX button, and actually Excel calls the mean what you call the mean. It calls it the average. And if you look here, it'll tell you returns the arithmetic average, the arithmetic mean of its arguments, which can be numbers, names, arrays, or references that contain numbers. And a lot of times, if there's several different words that mean the same thing, it'll explain what the difference between them is, or tell you how it's going to calculate it. So when I choose that, again, I just tell it this is where the data is. Okay, and it says the mean is 417.09. I can ask it to find the mode, and this is where it's going to fail me a little bit. Cancel that. So there are some things that you do kind of need to know for yourself. We can go down here and we're going to find the mode, but there is multi and single. I don't know whether that has more than one mode or if it has just one mode. So I'm going to ask it to find the multi-mode, which returns an array of the most frequently numbers, and it's supposed to tell me all of them. So again, I select the data. Be careful, don't select the tile, it doesn't like that. And it says that the mode is 200. But the simple fact of the matter is, it may not be, because if I go over here and have it actually sort from smallest to largest, I see that there are 3 200s, but there are also 3 500s, and it didn't tell me that. And there are 3 1000s, and it didn't tell me that. So don't totally trust it to find the mode. Sort the data and count for yourself. Okay? And there's a lot of much more complicated calculations that Excel and the calculator can do for us. I chose to show you Excel today because I didn't want to take the time to have us actually have to type all those numbers into the calculator. In Excel, I could just copy and paste. Okay? Questions from anybody?
The sampling lab, like with my car, if they want to go get it to the grinding,
Okay.
go get it as the classes over.
No, bring it with you next time. Bring your sampling lab the next time. And probably we'll go over the beginning part of class. Okay? Also expect a little short quiz at the beginning of class next time over chapter 1. You'll be over chapter 1, probably on sampling methods, because I had planned to do that on Monday. So we'll take about the first 5 or 10 minutes of class and do that sample. We'll talk about that activity in a minute, and then we'll immediately do a quiz.
So that activity, we don't need to turn that in?
Yeah, the sampling activity, if you turn.
Or it's not the worksheet?
The worksheet, yes, please turn in worksheet 1.1 through 1.5.
So is the pie chart and bar chart due date changing?
They are going to change. I will move them out. I'll probably bump all of the lab dates out by 2 days. Because I try not to have everything come due on the same day. I could just move those first 3 out. But you can go ahead and work on all of them and do your samples. And now that you've got the data, you can get finished with the rest of it. But yeah, I will move the due dates out on your labs a little bit. No, that's fine. And please don't forget to turn in your 1.1 to 1.5.